Welcome to Two Bees in a Podcast, brought to you by the Honeybee Research and Extension Laboratory at the University of Florida's Institute of Food and Agricultural Sciences. It is our goal to advance the understanding of honeybees and beekeeping, grow the beekeeping community, and improve the health of honeybees everywhere. In this podcast, you'll hear research updates, beekeeping management practices discussed, and advice on beekeeping from our resident experts, beekeepers, scientists, and other program guests. Join us for today's program, and thank you for listening to Two Bees in a Podcast. Welcome to another great episode of Two Bees in a Podcast. In an effort to continue to internationalize our program, we are going to be interviewing a beekeeper from Barbados, David Smalls. David is a friend of the University of Florida Honeybee Research and Extension Laboratory. We've partnered with him with beekeeping educational opportunities in the Caribbean, and he's going to be talking about beekeeping in Barbados. That will be followed by a visit from Dr. Cameron Jack, who's a lecturer and researcher at the University of Florida Entomology and Nematology Department. He is our laboratory's expert on oxalic acid. I get tons of questions about oxalic acid, and Cameron will be here today to talk to us all about it. We've got an exciting segment for you here in Two Bees in a Podcast. Just for purposes of introduction, though, I'm Jamie Ellis, accompanied by Cameron Jack. Hey, Cameron.
Hey.
Are you excited about this segment?
I'm so excited. I've got goosebumps.
You should have said bee bumps, man.
No, because there's a strict no bee bun policy.
Yeah, that's right. I forget. So I'm excited because we're going to talk about beekeeping in the Caribbean, and we have with us a guest from Barbados, who is a beekeeper himself, Mr. David Small. David is a beekeeper for the National Conservation Commission in Barbados. David, welcome to Two Bees in a Podcast.
Yeah, thank you for having me, Jamie.
Absolutely. We are fortunate because we've known you for many years, and you're always coming to the University of Florida to see our bee colleges. I know we've done some educational events in Barbados. For some reason, I've never made it down to Barbados myself. We need to change that. But we're going to start just kind of from the beginning. David, tell us a little bit about how you got into beekeeping. Before we started recording, you told me you started keeping bees in 1977, and something else great happened that year. That was the year I was born. So you've been keeping bees as long as I've been alive. So how did you get into beekeeping?
Well, I got into beekeeping when I first started working with the Ministry of Agriculture Soil Conservation Unit. Mm-hmm. There we had about 100 hives, 60 in one location and another 40 in the next.
Wow. So you just kind of jumped right in. That's a lot of bee colonies for someone usually in the islands to have. Mm-hmm. There's not, it's pretty, so.
And the thing is about that, when I first started, there was just a veil, long sleeve shirt, and I got murdered.
So at least you had a veil.
Well, you persisted though. I mean, that was 42 years ago, and for some reason you're still doing this.
Yeah, because as a kid, I was always interested in bees.
Really?
Mm-hmm.
So you had seen other people keep bees, or you just
not really? We made fun. Oh. Like we would take a bee, put it in a matchbox, take a piece of grass and make an aerial and put it into your ears. So you got a radio.
So you put a bee in a matchbox, put a piece of grass in it, and then stuck it on
antenna, and then you listen to the ears. But sometimes you will get sting.
You guys find interesting ways to entertain yourselves.
That's just kids in general.
Yeah, I guess. At least you weren't pushing over colonies or something like that. All right. So, we've got some questions that we came up with you behind the scenes, and I'm curious in the answers to these myself. So when did beekeeping in Barbados start? Honeybees aren't native to the Caribbean either. So when did they start?
They were brought in from Europe by the European settlers when they first discovered Barbados in about 1658.
So I'm assuming they were brought over in log hives or skips, similar to the way it was introduced, the way they were introduced into North America?
Yeah, I would believe so.
Yeah, that's only like 30 some odd years after the introduction to North America. That's pretty interesting. They were getting down there that quick. It's also interesting to me, was Barbados the major sugarcane producer?
Yeah.
Okay.
We were also producing cotton at the time.
Interesting. So it's like they brought over with them a sugar source in the bees, but there was already a significant sugar source on the islands, given that there's so much cane growing.
Mm-hmm.
That's interesting. So today, how many beekeepers are in Barbados?
I think there are about 50 plus.
What's the population of Barbados?
280,000.
So out of 280,000 people, only 50 of them are cool.
What's happening now, a lot of Barbadians are now becoming aware of the importance of the bee stash.
Sure.
So that's hence the expanding beekeeping population.
It's so interesting you said, because I've been to a few Caribbean islands, and it's always in the neighborhood of 50 to 100 beekeepers. You go around the islands and think that there's so much potential for more beekeepers, but why do you think there's only 50 beekeepers or so in Barbados?
Well, that is registered.
Okay.
Oh, okay.
So you think there's probably more, and they're just not
Yeah,
being...
because during my work, I go to visit like beekeepers, give them advice,
Mm-hmm.
and there's some on the radar that are not registered beekeepers.
Okay. So how many colonies does the average beekeeper keep?
There's one beekeeper on island. He has about 200. Then there's some between 10 to 15, and then you have some between 1 to 10.
So
Okay.
You've got one who's got 200. So that would
He's the largest. He's the largest. Probably the first commercial beekeeper on island.
would that be a full-time job managing 200?
Yeah, for him. I think
Okay.
he has about 2 or 3 workers.
Okay.
Yeah.
So what colony number is your cutoff for commercial? Like if I have 50 colonies in Barbados, is that enough for me to be a commercial beekeeper?
Probably 10.
10.
Yeah. So, I mean, what do the commercial beekeepers primarily do? Are they there for honey production?
Yeah, just honey basically.
Honey, basically, because I mean, I'm sure pollination happens. It's just,
Yeah.
but they're not moving bees around to pollinate.
I think it's because of the size of Barbados, which is 14 by 21.
Miles.
So then, bees travel between 3 to 5 mile radius. So hence, then there's no need like for pollination services.
Right.
But up until Sunday, there was a guy we had our annual AgriFest exhibition,
Yes.
agriculture exhibition.
Yeah.
And there's a guy who wants bees like one hive every 3 months now for pollination. So it's expanding.
So it's 14 by 21 miles.
Mm-hmm.
You've got 50-ish beekeepers. How many bee colonies are on the island, roughly? I know it's hard to know since there's...
Yeah, but in the wild, we had some research done by students from McGill University.
Okay.
And there could be over 100, 200 plus wild beehives.
Wild beehives. But how about managed beehives?
Managed beehives could be around close to 500.
So there's somewhere in the neighborhood of 500 to 700 when you roll in the managed and the wild or feral bee colonies, somewhere that many on that. Do you think the island can support more bees?
Of course.
Oh, interesting.
You see, what I said that is because our flora is diverse. It is not mono as such.
Yeah. Can you make honey year round in Barbados?
Yeah, I would believe so. Because when we first started, we got honey twice a year. Sometimes you get honey in January.
Wow.
You get honey in July and probably October.
Interesting. David, can you tell us a few of the big nectar sources that are on the island?
It is sea grape,
Yep.
manchineel, we call fatport, and then there's something called we call it Christmas bush.
Christmas.
Yeah, that probably blooms for about 3 months.
Does it bloom in winter? Why is it
well,
called Christmas bush?
I think because of the white flower it produces.
Okay.
And it has the leaf shape like a Christmas tree.
Okay. So would it be safe to say then that the majority of your honey is kind of multifloral sources?
Yeah, multiflora, yeah.
Okay. Is it a lighter honey generally or darker honey on the island?
We could get light. We'll call it very light.
Mm-hmm.
And then amber, and then there's a dark.
Okay.
It depends on what the bees are working. And
Sure.
there's a vine we call Corlita. And the other Caribbean islands, some call it graveyard vine.
Okay. I guess it grows in
Yeah,
graveyards.
because they find it in the cemeteries a lot, right?
Okay.
But I think, well, as far as our flora sources, I think we are good in that direction.
Okay. And Barbados has a lot of topography, right? There's a lot of mountains and hills. So it may be a 14 by 21 island, but it goes
but
up.
a lot of mountains and hills are our highest as well. 1104, which is Mount Hillaby.
Okay.
Well, so what are some of the challenges that the 50 or so beekeepers are facing in Barbados?
Yeah, right now the challenges are like Varroa, as for the disease.
Of course.
And then I think there's lack of education. So my job at NCC now is to try to educate the people on the importance of honeybees and why we should not say kill them.
Sure.
Sure. And I mean, and probably a lot of training to help beekeepers learn how to manage, how to treat for Varroa. So what are some of the ways that they're controlling Varroa?
Well, funny enough, I don't think we ever treated Varroa.
Really?
For Varroa, but and looking at the beekeeping industry after 2003-4, I don't know if the bees sort of develop a trait or become tolerable to the mites.
Naturally tolerant.
Yeah. Because when David was down, we did a little sample at Mount Gay, and we found some of the bees was less than 4%.
Interesting.
Any mites, yeah.
So I want to put this in a broader perspective. So what you're saying is after the introduction of Varroa, because you did not have access to treatments, really what you've had are populations build a natural tolerance. When you've sampled them before, you were finding 4 mites or more per 100 bees, but the bees, I guess, weren't dying?
No.
But they were suffering in other ways.
Again, it's funny, that I went to the hive at the Ministry of Agriculture last Wednesday.
Sure.
And examining some drone brood. I find it was about 10 mites out of 20 samples taken, and which to me is high, but the bees still look pretty healthy.
Sure. So that's interesting because, you kind of hear, I've heard this for example, from Puerto Rico. They have an African bee strain there that they believe is quite tolerant to Varroa and other pest or pathogens. And this idea is that on islands, you can get pretty intense selection, especially in islands maybe like in the Caribbean where there's not easy access to treatments. And so you kind of just have to let nature take its course. And then not so long after that, you get this bee population that might show some tolerant traits.
Yeah, I think, that could be what's happening in Barbados.
Okay, so go ahead.
Normally, the first time we knew about treatments for Varroa is when they came up to my first bee college in Grenada, which is in 2013.
Interesting.
Not knowing that there were treatments out there.
Really?
Yeah, for Varroa.
So they weren't even aware that there were options to treat for Varroa.
Yeah, exactly.
That's interesting. So you've got Varroa as an issue. It sounds like maybe it's flatlining as an issue. You guys are able to manage it in other ways. You mentioned education is a big issue, and Cameron was asking you some questions about educating beekeepers, and that's important, right? But what are some other issues that you see for beekeepers in Barbados?
Pesticides for the farmers.
Okay,
yeah.
So pesticide exposure.
The farmers are just, every day you pass, you see some at midday spraying, and it's probably taking a toll on the bee population.
Okay. You had mentioned, behind the scenes too, access to beekeeping equipment.
Yeah, because we have to import all of our equipment from North America.
Yeah, okay.
And some things, right now, there's a challenge because at NCC, who brings in equipment to sell to the beekeepers, it takes us about 3-4 months to get the order out, then another couple of weeks to get the equipment done.
Okay. So, I see this trend across a lot of Caribbean islands when I visit. It's very common to have lack of access to beekeeping equipment. It's almost always the case that it has to be brought in from North America, which usually makes it relatively exorbitantly priced, right? So it's more expensive maybe for you to purchase it than it would be for me. And then you have to get it down, and the resources to build your own colonies, access to Varroa treatments. I mean, there's all of these kind of things that compound to make it difficult. But you guys still persist, right?
Yeah,
You still keep bees.
Yeah, of course. Well, I mean, it's, if you love beekeeping, you love bees, you want to help save your country in terms of food shortages, then I guess that's the way to go.
Do most of the beekeepers that are actively making honey, I mean, are they just selling kind of at local markets, or are the beekeeper you mentioned that has 200 hives, I mean, is he selling or exporting honey, or is it mostly kind of everything, all the beekeeping operation kind of stays on island?
Yeah, he sells in the supermarkets, but when there's honey available, it just disappears at source.
Really?
Really? So you could just get rid of it that quickly, huh?
Yeah, it's in high demand, especially Barbados honey.
That's pretty incredible. Do you guys have any queen industry, or if I were to move to Barbados, which I can't, my wife would make sure I have to stay here and finish out my years working at the University of Florida. But if I were to move and I wanted to purchase bees, how does that happen? Where do I get my bees? Where do I get my queens?
Well, there's no queen breeding program on island as such.
Okay.
Hence, if I may mention again, David, he came down and he's trained out to get beekeeping, breeding, queen breeding program.
Sure, and you're referring to David Westerveld, who was the former assistant chief of apiary inspection here at the Florida Department of Ag and Consumer Services. He flies down quite a bit and does some education on Barbados. And so you said he's trying to maybe develop a beekeeping or queen rearing program down in Barbados.
Yeah, which is true.
Okay, and so what characteristics would you go after with Barbadian queens? Did I say that right? Is something from Barbados?
Barbadian.
Okay, there you go. That's what I get for trying.
There is a need for a vibrant queen rearing program on island. I was doing some research with Arista, be researched out of, I think, the Netherlands.
Okay.
And what was done is they look at the purple-eyed brood and the worker cells.
Okay, purple-eyed brood in the worker cells, yep.
And we found out, we looked at whereby the bees, like they had the VSH trait.
The VSH trait, yep.
And also, how should I put it?
Do they have hygienic behavior as well?
Yeah, you can see. But we never really, you can see like where if they detect these, you can see whereby they open back up the cell.
They will open back the cell. Okay, yeah, sure.
Sort of disrupt the program.
So you've lived in Barbados, right, your whole life. You've seen beekeeping in America. You just love what you do down there? You just enjoy working the bees? The island life is good for you?
Yeah, getting to do some good fishing.
That's right. Well, great. I mean, this is really interesting, David. I mean, it's just a very kind of unique perspective from this island and from the beekeeping there. If there's anything I can do, if you want to invite me over, I would be more than happy to come.
Do some educating, right?
I could bring some students. We'll go down. We'll talk bees and maybe talk Varroa, because I want to know what's going on over there. If you guys are
Cameron, that's a grand offer. I think that's really gentlemanly.
Yeah, thank you. That's very. I mean, I'm a generous guy. So.
Yeah, that's very good.
Right now, we are trained to have Dr. Ellis down.
Okay, who's
to
that?
See if he can, Jamie Ellis, to see if he can help us boost our educational system as far as beekeeping is concerned.
Great. Let me ask one more question with regard to islands, because I see this a lot too on the islands when I travel around down there working with beekeepers. Do you feel that beekeepers in Barbados have a good understanding of the diseases and pests? Or, for example, if there were a national survey of diseases and pests in Barbados, do you think that you guys would find things that you weren't aware of? For example, do you have American foul brood? Do you have European foul brood? Do you have deformed wing virus? Do you have chalk brood?
Yeah, we saw some deformed wing in a sample last when David and Bo was down last. But apart from that, I haven't seen any nosema, nothing yet.
So, because what I see a lot in the Caribbean islands is that they just don't know what they do have, because there's been no proper disease and pest screens, molecular screens looking for the different viruses and bacterial diseases, et cetera.
Exactly. That is why we need someone like you, maybe Cameron,
sure,
to come down and sort of point us in the right direction.
Yeah.
In terms of looking for pathogens and diseases.
Yeah, I think that's a significant need kind of in the Caribbean. A lot of the islands I visit, they know they have Varroa, because that's the thing everyone talks about. And some of them know they have small eye beetles, as an example. But some of these other diseases and pests are just not known if it's there or not, because there's been no proper screening to see.
Because the bees look healthy, so we're seeing the bees.
Exactly. Well, David, you've been a great interview. I really appreciate you joining us.
Yeah, thank you.
That's David Small, beekeeper for the National Conservation Commission in Barbados, talking about keeping bees in Barbados. Thank you for joining us on Two Bees in the Podcast.
Yeah, thank you for having me.
Absolutely.
For additional resources, visit the podcast page on our website, ufhoneybee.com.
In this segment of Two Bees in a Podcast, we are going to deal with more issues related to oxalic acid. I'm your host, Jamie Ellis, accompanied by Cameron Jack.
Thanks for having me back.
Having you back and Cameron Jack kind of rhymes.
That's right. It's always a party with Cameron Jack.
But that doesn't rhyme.
No, well, I'm not a poet.
Cameron, you're here because, of course, you work here at the University of Florida, but also you are our resident expert on all things oxalic acid. And I was just sharing with Amy kind of behind the scenes before we started this segment that, I write a column for the American Bee Journal. It's called The Classroom. And so beekeepers send me lots of questions that I'm supposed to answer. And without question, a lot of the questions deal with oxalic acid. People are just interested in this topic. I know that we already had this discussion in an earlier podcast, but it's come up again. And the reason it's come up again is because one of your research papers for your PhD dissertation has been published online, so it'll be published in print pretty soon. It's entitled Evaluating the Efficacy of Oxalic Acid Vaporization and Brood Interruption in Controlling Honeybee Pest Varroa Destructor. So you and I and a colleague, we did this work. You've got some data, and we got a lot of listener questions about it. It's great, number one, that beekeepers are out there are reading our research and presumably research from other labs, but it's also good to know that they're wanting to know more about it. So Cameron, if you don't mind, we can talk about this some.
Yeah, great.
So we'll just kind of start from the beginning. I'm going to ask a couple of general questions before we get down into your research. What are ways that oxalic acid can be used legally at the moment?
So according to the label, there are 3 legal ways to apply oxalic acid to your colony. So the first one that probably has been around the longest, that probably most people are familiar with, is called the trickle or the dribble. I mean, people call it different things, but basically you're mixing oxalic acid dihydrate into a sugar solution, which sugar syrup, and that you are then trickling between the frames.
Using kind of one of those big plastic
Just a big old syringe,
Mm-hmm.
but it's only like 5 milliliters per frame. So you're putting 50 milliliters per colony. But it's been pretty effective, and people have been using it for a long time.
And how often do you do that? Is it a single treatment, or do you do that multiple times?
I think that kind of depends on the year. You can do usually up to 3 once per week.
Okay. Gotcha.
But it kind of, best case scenario, the beekeepers are sampling and monitoring their Varroa populations. They don't overtreat, but do what is going to be effective.
So listeners, it's important that you hear me say this. It doesn't really matter what Cameron and I say on this podcast. What matters is what the label says. So the label's the law. So regardless of what we talk about, kind of research from behind the scenes or our perspective, the label is what you legally are obligated to follow. So I just wanted to throw that out there before we get too far. So oxalic acid is best used in the dribble method probably when colonies are broodless, right? Because at any given time, a lot of the mites are in the brood and therefore not exposed to the oxalic acid treatment. Therefore, the treatment once a week, every other 3 weeks in a row or something like that, right?
Yeah, and that's really, I think you can make that statement for pretty much any Varroa treatment.
Mm-hmm.
It's going to be most effective when the colonies are broodless, but especially so for oxalic acid, people definitely want to use it during the winter months when the colonies are broodless.
So that's the trickle method. What are the other 2 methods?
The other one is similar to the trickle method. This is just called the spraying method, where you'd mix the same solution, but you apply it by spraying it to the sides of the frame.
Okay, so both of those are just topical exposures.
Exactly.
All right, gotcha.
So then the third method is vaporization. And so this is, if you think back to your chemistry days, vaporization is taking a solid to a liquid to a gas, whereas sublimation is taking something from a solid straight to a gas. So
Cameron, that's very important before you go any further, because I hear beekeepers routinely call it, we use oxalic acid sublimation or we use oxalic acid vaporization, and people are always asking me the difference, so I want to see if I can get it correct based on what you said. Vaporization is taking something from a solid to a liquid, then to a gas. Sublimation is basically you are skipping the liquid phase and going straight from the solid to the gas. Yep. So my question to you is do we actually sublimate oxalic acid in the U.S. or do we vaporize oxalic acid in the U.S.?
So it depends on what you're using. So if you're using oxalic acid straight, just pure oxalic acid, which most people don't.
Okay. If
you're using straight oxalic acid, you will take it from a solid to a gas. So you're doing true sublimation.
So sublimation.
If you're using oxalic acid dihydrate, which is what you're supposed to use according to the label for the United States.
Okay, so the thing that's actually legal to use
is oxalic acid dihydrate, which is going to vaporize.
Okay, so the vast majority of beekeepers who are using the labeled treatment, they're actually achieving vaporization, not sublimation.
I would say the vast majority across the world are using oxalic acid dihydrate.
Okay.
And so in a lot of the research papers that we, would read from old studies, they say they sublimated OA, but then they'll still say that they used oxalic acid.
So they're just wrong.
They're just wrong.
They just don't know.
I mean, this is something that we've learned fairly recently as well. I mean, I've just through some research, somebody actually corrected me, and I went back and really focused on this, and I said, you know what, they're right, and so I'm learning too.
Okay, so those are the 3 kind of labeled ways in the U.S. And again, if you're listening, that labels change all the time, so you have to follow the label, and if application changes, you need to change with it. So let me give a little bit of background then. Some years ago, I was visited by an Italian colleague who said that in Italy, a lot of commercial beekeepers will create artificial brood breaks at times of the year that colonies would not otherwise be broodless. In fact, he was saying that the Italian commercial beekeepers were doing this in summer. And they would create these brood breaks by caging a queen for X number of weeks so she wouldn't be laying, and then you'd get this natural brood break, and towards the end of that brood cycle, when all the brood has emerged, then they would treat with oxalic acid per labeled rate. And they were saying they were getting very good control. So that's kind of the background. Then you came here to start your PhD. You're now a faculty member, but you came here to start your PhD. And one of the projects you did is you wanted to look at just what the Italians were doing, this combination of oxalic acid treatment and brood breaking on the impact of Varroa populations in colonies. So that paper, so for the listener, we're recording this podcast in February 2020, so that when you're listening to it, you'll know. But that paper just came out online. It's going to be in print soon, and some beekeepers are already seeing that paper and asking us questions related to oxalic acid vaporization and the control we got in that particular experiment. And we thought this would be a good time to go over this project, which I think would help beekeepers kind of understand the strengths and benefits, but as well as the limitations of using oxalic acid treatment, as well as allow us to discuss a little bit about this brood break, right?
Sure.
All right. So can you give me an overall setup for your experimental design? I mean, what did you do? What was the purpose of this study? What did you do? And then I'll start reading for you some of these listener questions that we've had.
So the first thing I want to say that oxalic acid has been tested, a fair bit in the United States, mostly actually by Marion Ellis's group out in Nebraska, kind of in the late 90s.
Cool last name, but no relation. Uncle Marion. Actually, believe it or not, Cameron, he came from an area in Tennessee where a lot of my father's family came from.
You're probably cousins.
Maybe we're related, but at the moment we don't know. Maybe 23andMe. Maybe it's time for 23andMe to tell us. There's been some oxalic acid research that's happened in the United States, but nobody's ever really looked at vaporization. This is it's not necessarily a new application method, but it's kind of more recently in the last few years caught on in popularity. So we wanted to test that one, but we also wanted to kind of, as you mentioned, kind of test this a way that a lot of the Italian beekeepers were claiming they were getting a lot of success by creating these brood breaks. And then the idea is when you get rid of all of the brood inside of a colony, that there's no place for those mites to hide. I mean, they're going to be on the bodies of the bees. And so the idea is they're more exposed. And so in one fell swoop of a good treatment, you should be able to knock down all the mites because there's nowhere for them to hide, right? So that's the idea. So what we wanted to do was to kind of test all of the different scenarios, basically. And we did this by creating a full factorial design. So we're testing every single combination of OA treatments and queen caging or this brood break, right? So we have, so there's also different schools of thought too. Some people will say, well, you don't need to cage your queen. You just need to treat once per week for 3 weeks. And then the idea is that as the mites emerge out of the cells with the emerging bees, that they will eventually be accessible through treatment. Okay. Right? Yep. So Cameron, you approach this by doing kind of a factorial experimental design where you cage some queens but not others, and you treat it with OA 1 or 3 times but not others. So can you explain to me kind of this design?
Sure. So, I mean, basically we either cage the queen and then treated with 1 time with OA or or with 3 times with OA, or we chose to not cage the queen and then treat with one treatment of OA and then, or 3 times.
So let me
OA.
see if I understand this correctly. There's 6 treatments. So you either gave no OA, 1 time OA, or 3 times OA. That's 3 treatments.
Yep.
And you did all 3 of those in colonies that you caged the queen, and in colonies you didn't cage the queen.
Exactly.
So 3 times 2
Yep.
is 6.
That's it.
All right.
So we got it. And then just to make things, relevant to what current beekeeping practices are, I mean, we wanted to have what we would consider kind of a positive control. So we also had a 7th treatment that was just treating with amitraz.
So the industry standard. Yep.
Exactly.
Okay.
So so we have 7 treatments. We had 10 colonies per treatment. Field experiments are kind of hard. I mean, you want, obviously, best case scenario, I mean, we could have as many colonies as we could possibly manage. For this experiment at this time, we had 70 colonies to work with. And so that's why we did 10 colonies per treatment.
Sure. Yeah, I mean, that's an important point, listeners. We are always limited to time, people, and money. If we had unlimited time, unlimited staff, and unlimited resources, we could do 100 colonies per treatment. But in this particular study, Cameron, we used 70 colonies, so we were able to allocate 10 colonies of treatment.
Great. And so along with that, I mean, we started this experiment in September, which if you've been in Florida, it's Gainesville, Florida in September. I mean, it's still crazy hot. It feels like summer.
September, October, November are all summer months for us.
So we start this in September, and when we wanted to, for those that we were caging the queen, those treatments that received that treatment of having that brood break, we caged the queen for 24 days, exactly 24 days. And so some people have asked me since this paper has come out, why 24? That seems like a really long time. Well, if you think about the time that an egg is laid to the time that a drone would emerge is 24 days. So we essentially in that 24-day period have cleared out every possible brood that could be in that colony.
No brood left for Varroa to hide in. That's the premise behind queen caging or brood break. Yep.
And so those treatments that received the 1-time OA treatment, they were treated on day 24 when it should be all cleared out.
Sure.
On the ones that were treated 3 times, we treated them every 8 days. So you'd treat them basically once a week.
Sure. So that makes sense. And then you follow those colonies for X number of weeks or months to look at Varroa populations in them to see how they responded to the treatments.
Exactly.
All right.
And we did that for 3 months.
Yeah. And so if you had to summarize, just very quick summary, because I've got some more specific questions for you, but if it's very, very quick, succinct summary of what did you find?
So basically what we saw was that colonies that were treated with OA just didn't, they looked pretty weak. They didn't actually recover, even if they were treated 3 times. And if we caged the queen, they looked even worse.
Yeah.
And it just, the colony, none of the queens died during this experiment. I mean, they lasted that full 24 those full 24 days of being caged. We would release them and they would go right back in and they would start laying again. But they just couldn't quite recover.
So essentially the take-home message is neither brood breaking nor OA nor a combination of those 2 things reduce Varroa loads appreciably.
Yeah.
Okay.
Yeah.
All right. So, first of all, that's research, right?
Right.
Now, it's interesting. Anytime you do a project, it's limited by the conditions under which you do it, the number of colonies you use, the time of year, the location, how you set up the study. So there's 1,000 reasons that we might expect that we actually got those results, right? In my experience, and this is not negative, listeners, but my experience, oftentimes when papers get in the hands of beekeepers who are reading these things, they'll believe in OA so much that they are kind of upset that we didn't find that it worked. So they'll try to find all the reasons that it didn't work. So I want to talk to you maybe about some of the reasons OA didn't work, and I'm going to seed you with the first one. So rather than pick on the study design or anything like that, the first thing I'll say is just possible that level of OA doesn't work. I mean, the simplest answer is it just doesn't work. It's not effective.
Absolutely. I mean, when I would go kind of share this research with different organizations, different groups around the state and around the country, people would say, you know what, OA vaporization works great for me. And then I will ask them, did you do 1 gram for OA.
Yeah.
And then they always get that smile on their face, like, no.
Yeah.
And so, I mean, the point is we were doing what was according to the label. I mean, that was the treatment that we used, and we just didn't see.
Yeah, and what people don't know yet, because you haven't published it yet, but you also did a study where you looked at multiple levels of OA, and in that study, multiple doses of OA, and in that study, the labeled rate 1 gram also did not work. Now we do know a level that does, but we can't talk about it at the moment. We'll talk about that when that research paper comes out.
Sure.
But the point is that 1 gram of OA is probably not sufficient to control Varroa. That's just what we're seeing here in the South. Now, you are right. I also have a lot of northern colleagues who'll talk about OA working for them, but I just want to just ask you some questions. I mean, obviously, what do you think besides, let's just say, can seasonality have an impact on efficacy? Can the duration of queen caging have an impact on efficacy? These are questions that we're getting straight from beekeepers who have read this paper. Do you think the dose had an impact? And we've already talked about that. I think dose does, in fact. But what about seasonality, duration of queen caging? What do you think? What are some other things that could kind of come in play here?
Both of those kind of more, I think both seasonality and duration of queen caging kind of have more to do with the whether we can cause the artificial brood break. I mean, whether that can be effective. And I think, I guess hindsight's always going to be 2020. And so, ideally, we probably would have started this experiment a little bit earlier in the summer, but we just didn't have the colonies ready at that time.
Sure.
And in Florida, our like we already said, September, we have 3 months of what we would be considered summer. But nevertheless, so seasonality may have had an impact. If we, it could have. Maybe our colonies would have bounced right back after we released the queens if we had done this in the spring or summer, right?
Sure.
But we just don't know that yet.
Sure.
And as far as the duration of the queen caging, same thing. It's like, maybe 14 days would have had less of an impact, and those queens could have, jumped back in, started laying. But at the same time, then we would also have run the risk of still having capped brood in the colony, and then we wouldn't have known if our treatment was being as effective or not.
I think what was interesting to me when I was having these discussions with my colleague years and years ago is this is something that commercial beekeepers in Italy do. Now, I'm not suggesting that they're necessarily to the scale of the beekeeping operations that we have here, where we've got tens of thousands of colonies. But it was interesting to me that in hundreds or in a few thousand colonies that they were actually caging the queen. And what they would do is they could cause queen caging to last shorter periods of time, because what they would do is they would go into a full-size colony, cage the queen, and instantly remove all the brood.
Right.
And with that brood, they created new colonies, like nucleus colonies. And they would argue that these new colonies that were growing quickly would outpace the Varroa. So these nucleus colonies that had the brood didn't necessarily need an instant treatment. So that then would leave behind a parent colony that's now broodless with a queen caged for a week or 2 weeks that you could do these treatments. So you get a much shorter queen caging period by manually removing the brood. But if you do that, you've got to have a home for that brood. And their strategy was just to use that brood to create splits to grow more colonies. I thought that was interesting, but they were doing that again in the middle of summer, which is not when traditionally we think about OA applications in the U.S. You typically hear it preached as a winter treatment, but it can be done presumably if you have brood breaks. And so they were forcing it with queen caging or forcing it by physically taking out all the brood. I think that's another listener's question, are there other ways that we could have maybe reduced that 24-day caging period? I've just mentioned one right there, just physically remove the brood on the same day that you cage the queen. However, I struggle to see this being applicable to someone who's got thousands of colonies, right?
Yeah, the amount of time that it takes to find and cage the queen. I mean, a skilled beekeeper can hopefully do this, within a few minutes. However, when you multiply that by thousands of colonies, I mean, it's just a lot of, it's going to be a lot of time, and time is money if this is your business, if this is.
Sure. And we'll talk about this on a future podcast. I think you and I both believe what it's really going to take is a change in label rate.
And truthfully, I mean, that's what I hope happens from all this. What I want to do is, I want a legal treatment so beekeepers that is effective, so people can use it and rotate that into their arsenal against Varroa.
Yeah, I think that's what's going to happen. I think your other data plus some data from colleagues who we've been talking to about this suggests that it's going to take a higher label rate. Listeners, I know you want to know what that is at the moment, but if I said it, you'd all be doing it, and it's not been published yet, and it's currently illegal. So we'll get that published, and as soon as it's published, we'll talk about it on a future podcast. So I don't think OA is useless at all. I feel like it's got an important place. Now, one of the things that makes me nervous is I know, and I don't want you to go into too many specifics, but I'm aware that there's a lot of fogging with OA, it just being pumped out, like a fogger into colonies. And so can you talk about maybe some of the drawbacks or dangers in doing that?
Yeah, sure. There's definitely, there's different ways that people are applying this, and fogging makes me a little bit nervous for a couple of reasons. I mean, one is that you're mixing your OA into an extremely high, ethanol content. I mean, it has to have a really high alcohol level so that the fogger actually will work. And the idea is that you've got a propane tank and a heat source, and you're blowing this kind of into the colonies, but it should be, the idea is that obviously it's controlled, so you're not just using it as a flamethrower, but you're spraying in this pure OA. The problem that I have with the fogging is that you really don't have as much control over how much you're putting in. You don't really know.
The dose. Yeah.
You can. I mean, I've seen beekeepers told me they've drawn a line on their jar and they can kind of see, but at the same time you just don't know. I really like vaporizing for the sense that you can put you weigh out ahead of time, and you can put the exact amount that you want to treat with, and then that entire thing is treated, right? I mean, or that entire amount of OA is applied to that colony. So you have more control of the dose because, this is, like you said, I think there is a place for OA, but I think it has to be done carefully.
Yeah. I did have a question when in one of my columns for the American Bee Journal that I asked you already, and I think we've already answered it through ABJ, but I wanted to ask it here on the podcast is, when you vaporize with OA, you'll often get these residues of OA crystals kind of scattered throughout a hive, right? You'll get some on the, cappings of cells, et cetera. Is there any residual efficacy of OA after this, or do you think the efficacy that you get is through the vaporization? Like, and once the vapor's gone and those crystals form throughout the hive, it's over. What do you think there?
So that's a good question, and I don't know if I have an amazing answer, but we do know that OA will break down, kind of dissipate within the colony fairly fast, and it would have to be, when you do see it, that means it was probably, it just didn't dissipate very evenly or very well. And so there is there's definitely some residual effect, because we know that we don't know exactly the mode of action kind of on a molecular scale of what is happening. But we do see when Varroa are walking and they are walking on OA, it kind of basically clogs up or prevents they basically have suction cup feet, and it keeps them from being able to hold on, and they fall off. And it also increases a grooming response from the bees when it's OA is applied. And so the bees are grooming themselves like crazy. The mites can't hold on as well. They're going to fall off. But there's definitely another mode of action, because if I strap an OA down with a piece of tape and I put a piece
of Varroa, yeah.
Yes, what did I say?
You strap an OA down.
Well, no, that's a little bit harder to do.
Like, wow, that's impressive.
Yeah, no, that's hard. But
then you're a PhD when you can do that.
But if you strap down a Varroa and then you put a small amount of OA on, they will still die. I mean, there's definitely something happening that we haven't figured out, the exact mode of action for that. But as far as it staying within the colony and lasting for a long time, we really don't see that. I mean, it will go away.
Sure. So
that's one of the benefits of OA, I mean, in my opinion.
Yeah, and given the interest in OA and the desire of people to use it, do you kind of have any last recommendations for us? If someone wants to use it, what are you going to recommend to them?
So I'm not going to recommend any specific brands, because nobody's paying me to say that or anything.
Well, even if they were, we shouldn't be.
Yeah, that's right. Well,
which they're not, by the way, guys, so don't panic.
But there are some newer models of vaporizers that just really seem to speed up this process, and I think that is I mean, what draws a lot of people towards fogging is because they say, look, I just mix this once and I just have to give it a few puffs and I can go on. And I get that. I mean, it's nice to have something that is just speeds up, because if just the kind of traditional vaporizers are just like a hot metal spoon that you're sticking in that colony, and it takes a few minutes. So you have to have multiple.
You're heating white crystals on a hot metal spoon.
It seems like it should be something that is.
We are talking about oxalic acid.
Yeah, you put on your magic crystals and then So it seems like it should be illegal.
Podcast,
but it is a legal treatment. But my point is that takes a long time. Always a legal treatment.
Yeah, we need to get back on track.
That kind of method of application takes a long time. So there are some newer models that just heat this up faster, and it's not necessarily the temperature is going like crazy high through the roof. It's just that it kind of spreads out the OA a little bit faster and kind of heats it a little bit more even, and just allows, and it does get it to a little bit high of a temperature, but you don't want it to be like insanely high, or else you can actually basically combust the OA into something else, formic acid and carbon monoxide, and you don't really want to be pumping that in your colonies. But
so I hear.
So you basically, so these models do help you kind of speed it up, because you can kind of pre-weigh out your OA, and then you can, within just about 5 seconds, you've treated that colony. So there are ways to kind of speed this up, and that I think are going to make it more accessible, especially for commercial beekeepers or sideliners that have a lot of colonies that they need to treat.
Well, there you have it, folks. OA information from our OA expert, Cameron Jack, here at the University of Florida Honeybee Research and Extension Laboratory. Thanks, Cameron.
Yeah, glad to do it.
Guys, if you have more questions about oxalic acid or its use, you can continue to listen to us on Two Bees in a Podcast. You can go to our social media sites at UF Honeybee Lab and post those questions, and we will try our best to answer those questions in the question and answer session of Two Bees in a Podcast.
It's everybody's favorite game show, Stump the Chump.
Today's question and answer time is going to be all about drones.
It's about time the guys get some attention.
Yeah, I
feel like every time we're with Bee, we just keep talking about all the great females and all the cool things they do.
I mean, they're pretty awesome, but drones, I guess they deserve some credit too. They do things sometimes.
Yeah, they do play a seemingly important role in the life of the hive.
Seemingly, yes. So we actually got questions from someone named Dan. He's a field ecologist for the National Ecological Observatory Network. He sent us an email and he kind of had a few questions about drones. So I'll just go ahead and ask him, and hopefully, Jamie, you can provide me some answers.
Well, I'm just impressed that he's a field ecologist for such a prestigious organization. That's cool. Maybe I should ask him some questions.
Seriously, we'll be emailing him sometime.
All right.
So the first question we have is, should we select should I selectively and time-consumingly remove drones? I've been toying with this idea.
Okay, that's a great question. So for the benefit of the listeners, the motivation probably behind that question is that there are some recommendations out there that drone removal can confer some level of Varroa control. So let's think this through. First of all, drones are males, the male honeybees, and the bees colonies tend to invest heavily in the production of drones in spring, because that is when queens themselves are being produced. And when you have a flush of virgin queens, hitting the wing, they need a flush of drones to mate with them while they're flying. Now, of course, we all know for biology reasons that drones from a particular colony do not typically mate with the queens from that colony. But nevertheless, drones are a huge energy investment from colonies, right? Colonies put a lot of energy into producing those. Drones also happen to be the favorite bee for Varroa to parasitize. Now, we know that Varroa feed on adult bees, but they have to reproduce on immature bees. So preferentially, they go into drone cells. Now, they will go into worker cells as well. That's obviously a big problem for us. But given the choice, they will invade drone cells, which will have a disproportionate number of workers in those drone cells. So all of this led to this idea that if we occasionally go in and destroy drone brood, then we are killing a significant, not like a huge chunk, but a significant piece of the Varroa population. So this has led to recommendations about using drone combs, where if you've got a 10-frame hive, you can replace one of those frames with drone foundation. When the queen populates it with drone eggs, and the larvae come out and develop to the point that they are sealed in their brood cells, then you can freeze that frame because there's lots of Varroa in it. Then you can take that frame back to the hive and the bees will clean it out and the colony will start over. Some people who don't use drone frames then propose the question exactly as now. Well, should I just go in and occasionally destroy some drone comb, hopefully to get a handle on Varroa? So it is labor intensive. I do feel it's a reasonable Varroa management strategy for hobbyists. I think once you get up to the sideline or commercial beekeeper level, it's not very practical. So my answer back is, it all depends on how much time you're willing to put into bees. If you're actually using a drone comb, there's not a huge time investment. It's just every time you work your colony, or, once those cells are capped, you freeze it for a day or two before you return it back to the colony. But if you're talking about destroying drone cells systematically every time you work your hive, I think that's not worth the energy. I would suggest controlling Varroa other ways. But long story short, if it's something, if you're chemical averse and you've got a lot of time and this is a strategy you want to use, it can certainly help. But most beekeepers find it a little too time consuming to try to use this strategy to control Varroa.
Got it. So with all the drones kind of eating away and coming in and using resources, could they be impacting the available food source for developing larvae?
Yeah, so obviously this is another good segue question. So, we've just dealt with this idea, should I kill drones for Varroa control? And my general recommendation is, unless you're a hobbyist and have a lot of time, you really probably shouldn't go that route. So now the question is, well, do they consume a lot of resources? Maybe I should just get rid of them because they have no purpose and consume a lot of resources. And I've seen wonderful presentations given at the state and national level about why drones are important. We've got this idea that they tax our colonies. They're an energy sink. We need to get rid of them so that bees can put that energy elsewhere. But drones are important. We need good drones to go out there and mate with the virgin queens. Even if they're not our own queens, we want to make sure the bees around us are the type of bees that we want to keep, and we can do that by producing good drones. I also tell people bees are going to try to make drones anyway. And so if you're selectively destroying them, they're going to go through the process of creating them all over. So I'm
Yeah.
not sure it's an energy saver for us to do that, because the bees are going to keep trying and keep trying and keep trying. So I don't know that it's worth it just to save a little bit of food resources for the bees.
Got it. Okay, so for the last question that we have, in one of his 5-frame nukes, he believes that he's seeing 2 distinct size classes of drones. Is this possible, and why, if it is?
Yeah, so you can get different sizes of drones in the colony. I will tell you, there's a few reasons for this. One possibility is that it's a nutrition issue. Perhaps some of the drones didn't get quite the level and quality of nutrition that the other drones did, so they developed smaller. But honestly, Amy, a lot of it has to do with the cell in which they were raised. I want you to think about it from this perspective. When we give our colonies foundation, that foundation is worker brood sized. So bees, in order to have drones in a standard colony, they will take a messed up area of comb and construct drone comb in that area. And if you look closely at that drone comb, often there's a lot of varying sizes of those drone cells because they have a limited space to make it. So you'll get small cells and bigger cells. When you give bees unadulterated ability to make drone comb, it's very uniform, large cells. But in our colonies, you get these varying sizes of cells. So what you do is you get these queens laying eggs that are cells that are just too big for workers, but not quite the size of a drone. And the drone that's developing in those smaller cells will get proportionately less food, will have a smaller environment to develop. So it could just be an artifact of, you've got some big cells in which drones are growing up and some small cells in which drones are growing up. So nutrition, cell size, and I know a lot of people wonder too if perhaps there's some cryptic reproduction by worker bees, but I don't think that happens enough to where you would regularly see different drone sizes. And a last point to mention is that drones drift. They have a high propensity or likelihood of drifting. So if you have multiple colonies in your backyard and drones are freely moving between those colonies, then you may just be seeing different sized drones because the drones are from different colonies. You know, you could have some colonies producing bigger drone, other colonies producing smaller drones. And if they're randomly spreading out when they return back to their hives and are going in the wrong ones, and you're just going to see different drones, you know, from different mothers, even in the same hive. So that can be responsible for these differing sizes. So great questions about drones. It's all about the males.
It's all about the males. We're giving all the males a credit today. Thanks for answering those questions.
I tell you, it's funny. One thing though, Amy, is that I think he's getting at. We're useful. Here I am identifying as a drone. Drones are useful during the mating season, but when winter comes around, in a lot of temperate areas, the worker bees take care of the drones themselves. As you know, they kick them out of the hive so that they won't, in fact, be a tax on resources. But I won't mention that. I'll just mention how useful and beneficial they are for hives when they're not being kicked out.
I'm sure the drones are very thankful for having you as their spokesperson.
Yeah, there you go. We have to stick together, that's for sure.
We'd like to give an extra special thank you to the following: to our editors, Shelby Howell and Bailey Carroll, and to our audio engineer, James Weaver. Without their hard work, Two Bees in a Podcast would not be possible. So thank you.
For more information and additional resources for today's episode, don't forget to visit the UF-IFAS Honeybee Research and Extension Laboratory's website, ufhoneybee.com. Do you have questions you want answered on air? If so, email them to honeybee@ifas.ufl.edu or message us on Twitter, Instagram, or Facebook at UF Honeybee Lab. While there, don't forget to follow us. Thank you for listening to Two Bees in a Podcast.